Hi and welcome to Functions Day 1. Let's see, this should match your packets and your notes. First thing we need to do is go over some definitions. A relation is simply a set of ordered pairs. Okay? The domain is the first element in each ordered pair. Okay, in other words, that's your x values. Your range then is your second element in each ordered pair. So that would be your y values. And a function is a relation in which each element of the domain corresponds to only one element in the range. So what this means in English is the x values do not repeat in a function. And on a graph, it passes the vertical line test. Okay? So let's actually try some problems. For number 1, it says state the domain and the range for each relation. So the domain is simply the x values. So my domain is all my x values. I have 3, 4, 5, and 6. So 3, 4, 5, and 6. I'm using set builder notation, which is the fancy brackets, and you need to become familiar with this notation if you're not already. My range is in all my y values. I have 5 and 6 and 5 and 6. I do not have to write them more than once if they repeat. So just 5 and 6 is my range. For number 2, my domain is 2, 3, 2, 3, so it would just be 2 and 3. And my range is my y values, which is 1, 7, and 9. Because I have a 7, I have a 1, and a 9, so I just do 1, 7, and 9. When I have a graph, I look at things a little differently. To find my domain, those are my x values. And on a graph, your x values go from right to left. Sorry, wow, left to right, just like you read, left to right. Always start on the leftmost side and move to the rightmost side. So my domain is x. When I draw a straight line up and down, that means such that. Okay, the first x value I see, I have a closed circle, so it's included, is -1. And since it's included, it's less than or equal to x, because that's the domain. And it goes all the way up to 2, so we do less than or equal to 2. And my range is my y value such that my range, I start at the bottom and I go all the way up to the top. Bottom to top, looking at the graph. And the reason we write these differently than we did the first ones is the first one was just ordered pairs. It wasn't inclusive of all the points in between. Well, when you have a graph and you have a line drawn, that's inclusive of all the points in between. So my smallest y value is -2. So I write -2 less than or equal to y, less than or equal to, because I have a closed circle. My highest value is 1. Okay? For number 4, my pretty little graph here, my domain is x such that left to right, my leftmost point, I have an open circle. That means I can't include -1 as one of the points, so I just use a less than sign. And then go over to the right. The rightmost value is at 3, and I can't include that because that's a closed circle. My range is y such that start at the very bottom. And if I look at the very bottom, I have an open circle at -1. So it's -1 less than y. And then my top value, it's a closed circle, is 3, so less than or equal to 3. Now, it is possible, obviously, to have the same domain and the same range. It doesn't always happen. In this case, it's just coincidental. For part 2, write each relation as a set of ordered pairs. B, state the domain. C, state the range. To write these as ordered pairs, I would have 0 mapping to 1, 0 mapping to 2, so it'd be 0, 1, and 0, 2. Nothing goes from 1, so 2 maps to 1 and 2 maps to 3. So 2, 1, and 2, 3. Finally, 3 maps to 2, so 3, 2. So that's my ordered pair. My domain is all my x values. So if you look at the top, we're mapping from 0, 2, and 3. So that is my domain, 0, 2, and 3. My range is where I'm mapping to. I'm mapping to 1, 2, and 3. Okay? Okay, whenever you're given two drawings like this, x is always on the left, y is always on the right. So if we do our ordered pairs, 0 maps to 4, 1 maps to 4, and 2 maps to 4. So my domain is my x, so it's 0, 1, and 2. And my range maps to y, which in this case is just 4, because it's the only one being used. For the last one here, this one is kind of funny looking. the arrows are where they end. So 1 maps to 0, and 1 maps to 2, and 2 maps to 0, and 2 maps to 4. 3 maps to 2, and finally 3 maps to 4. My domain is all my x values. So I have 1, 2, and 3. And for part C, my range is what we're mapping to is 0, 2, and 4. Okay. For number 3, which relation is a function? Remember, this is always x, this is always y. In a function, x cannot be repeated. Okay? So looking at this, do my x values ever repeat? And the answer is yes, my x values repeat because Mr. Shaper maps to Leah and Allie, Mr. Campbell maps to Heather, Claudia, and Drew, and Mr. Miller maps to Jerry. So, since my x values repeat, the answer is no, this is not a function. And I'm just going to say x values repeat. So when I look back, I can remember. Okay? This is my next set here. And this one, none of my x values repeat, so yes, this is a function. For number 2, looking at my picture, we said that when it's a graph to be a function, it has to pass the vertical line test. Well, pass my vertical line test. I only cross my line once. So yes, this is a function. Doesn't matter if they're closed or open here because I only have one line. When I do it for the second one, the answer is no, because it fails the vertical line test. So it's not a function. For number 4 here, which of the following graphs is a function? Well, y equals x plus 2 is just a line. And you should know that a line, a linear function, is actually a function, all right? So what you want to do is think about what the graphs of these look like. So this is a line. And lines are functions. Y equals 6 is a special kind of line. This is a horizontal line. And if you think about a horizontal line along the horizon, it looks like that. If I were to draw a vertical line, it would only cross it in one place, so it would pass the vertical line test. So yes, this indeed is a function. X equals -2 is also another kind of line, and it's special. It's a vertical line. And a vertical line looks like this. If I were to draw a vertical line with it, it would fail the vertical line test miserably because it would touch it in every single spot. So vertical lines are not functions. X squared plus y squared equals 25. If you remember from last year, we did geometry. This is a circle. And a circle certainly does not pass the vertical line test. So this is a no. Y equals x squared. That is a parabola. Okay? Parabola y equals x squared looks like this. and that would pass the vertical line test. So that would be a function. So to quickly recap, domain is my x values, y is my range values. In order to be a function, my x values cannot repeat themselves. Or if I'm given a graph, I must be able to pass the vertical line test. Okay? All right, well, we will talk about this tomorrow in school. Thank you.